Oh, let me tell you this too. This is the week end preview. Now, did I say weekend? No, I did not. Okay? I don't care about your weekend. I hope it was wonderful. All right? And preview, am I talking about what happened last week? No, that's review. Okay? This is preview. The weekend preview. This is what's fixing to happen this week. Monday, I'm going to finish 5.4. On YouTube, it's going to be called 5.4B.
Is there a lot to it? Because I have half a page there.
There's more than half a page. Okay?
I have this.
Okay, so Paige can hand you a sheet of paper from over there on the bookcase. All right. Tuesday and Wednesday, you are working on worksheets. Okay? Worksheets. Y'all, this is factoring. The more you factor, the better you get. I gave you a lot of practice problems. Okay? I would advise you to work 10 at home and then whatever you can work during class. Okay? Thursday, you will have a 50-point test over factoring. If you can't factor, you will not pass it.
Wait, factoring as in like, you give like a trinomial and you break down a trinomial?
Oh, that'd probably be one of the easiest ones on the test. Okay? Friday, I have to go take care of my mother. So I will be in Arkansas. I'm leaving Thursday. You guys will do a little ACT, SAT practice.
Please tell me it's not like one of your
Huh? That's okay. Never hurts to practice. Okay? ACT and SAT practice. All right. And Mrs. McCullough will be here. So she can help you with it if you need some help. Okay?
There aren't any questions on there like, Kim bought 4 cookies. What's the circumference of that?
Yeah, I hate those.
No, they're not. I'll tell you that your ACT and SAT, it's even labeled. It's from chapters 2, 3, and 4. Okay? There's like three pages, front and back. Okay? And they're all multiple choice. And so the first page, front and back, is chapter 2. The next one's chapter 3, and the next one's chapter 4. Probably going to make it due like Tuesday or Wednesday of the next week. Okay?
Is it going to be a grade?
It is going to be a grade.
A test grade?
No.
Okay, good. What is?
It's because Miss Becker gives us SAT practice.
It's not the same, guys. I promise you. You're gonna look at this stuff. Look who's teaching you. You're gonna look at this stuff, pull out your little calculator, and answer 10 problems in about 10 minutes. You're gonna be like, oh yeah, that's right. It's gonna be amazing.
If we can do the worksheets, we'll always be able to do tests.
Yeah. Oh well. Oh, this test? Oh yes, because the worksheets are going to be more difficult than the test. Okay? All right, standard practice in this classroom. Okay, so here we go. We're going to review. We're going to do a quick review over 5.4a. Okay, just a quick review. Sum and difference of cubes. So, let's try this problem right here. X to the third minus 8. Let's do plus 8. Sorry. X to the third plus 8. Okay, so I'm going to factor this. Can I factor it? Yes, because it is the sum of 2 perfect cubes. All right? Going off task here for a second. Can I factor the sum of perfect squares?
No.
Yeah, y'all, you can never ever factor the sum of squares.
You have to have 2 conjugates.
That's right. And conjugates will give you what kind of sign right in the middle? Negative, okay? The only way to get rid of that inners and outers, which is going to be that X term in the middle, is to have different signs, all right? And those different signs are going to give you a negative 4 instead of a positive 4. This will not factor. Cubes is not that way, okay? So I'm going to tell you the directions. For those of you who were not here on Friday, there are 8 rules that we're following. They wrote them down. You'll either get them from somebody or look at YouTube. So, here it goes. Cube root of the first. You tell me. Keep the sign.
Plus.
Very good. Cube root of the second. Go back. That means close off those parentheses and open up a new set and go to the beginning. And then you go. Square the first. Change the sign. Take the product. Plus, always plus, square the last. Very good.
It's not as hard as I originally thought.
No, when you first write it down, you're like, oh my gosh. But after you do it about, I'm going to say 5, 6, maybe 7 times, then you're like going, oh, I got this. It's not that bad.
First 2 numbers, the rest of it.
Yeah. Okay, so let's do another one. Okay, are you ready?
Which one you want? I need the back. I'm going back. Okay.
16a to the third minus 250b to the third. What's the first rule, guys?
We're out.
Yeah, see if you can take something out. Guys, can you pull a 4 out?
Yes.
Can't pull 4 out of 250. Yeah, you can pull a 2 out. Okay? What do you multiply 2 by to get... Spencer still doesn't believe me. A 6 will come out, Spencer, but a 4 won't.
Oh.
Okay?
That's 2500.
No. All right. So, 2, what do you multiply 2 by to get 16a to the third? What do you multiply 2 by to get negative 250b to the third? Okay. So, oh, now I got, these are cubes, right? So now I have the difference of 2 perfect cubes. What's the mistake some kids are going to make right here? They're going to drop that 2. If you drop that 2, you're losing points. Okay? You have to keep all the factors there. Now, I'm saying the same thing that I said before. Cube root of the first. 2a. Keep the sign. Cube root of the second. Go back. You're going back to the first. Be careful here. Square the first. Very good. The first is 2a, and you have to square it all. Change the sign. Take their product. Always plus on the end. Square the last. Very good. Now, can I factor this? Okay. So if you weren't here on Friday, here's what we talked about. These 2 factors right here will never factor. Okay? Because here's the directions are going to say factor completely. When it says factor completely, my brain goes, hey, I need to get these all down to x to the first, right? But I look at these and my brain screams, you better factor that, but you can't. And the reason is because we only took the product and we didn't double it. If you doubled it, then you could have factored this thing. Okay? When can you ever find the factors of 4 that add to be 2? That's not happening, people. Okay? You can't have it. So, these will never factor. All right, so let's talk about today. Today, what's the second part of, thank you, 5.4b? And it is called group factoring. I love group factoring because it like can't sneak up on you. Okay? You know how sometimes the teacher teaches you how to do something and you like go, whoa, I didn't know that's when I was supposed to use it. Or you're like working a problem and then all of a sudden you get stuck and the teacher's like, well, this is where you're supposed to be doing it. And you're like, well, I didn't know. Okay? Well, this is never that way because whenever I see 4 terms, my brain's going to scream at me. Oh, it's a group factoring problem. Group factor. Okay? So, how do I know when to group factor? 4 terms. And that's going to be my sign. This is probably a group factoring problem. Alright? Okay, so here we go. First one. It's example 3 in your book. It looks like this. Now, I'm just going to work this problem and I'm going to tell you all the stuff and how to do it. It's not really hard. Okay? But there are there's a few places where kids make mistakes. So I want to point those out to you so you don't make those mistakes. All right, so it looks like this. X to the third minus 3x squared minus 16x plus 48. And it says factor completely. Now, whenever it says factor completely, my brain says, hey, I'm probably trying to get this down to linear factors. That's what they call them. But it just means it's an x to the first, okay? All right. So what's the first thing you look for when you're factoring something? Okay. Can I take anything out here? No. All right. So do I have 4 terms? Okay. So that's the group factoring thing. Now, I'm always going to try and group it the way they gave it to me. If it doesn't work that way, then I'll mix my terms up, okay? But I'm always going to try it the way that they gave it to me. I mean, if it doesn't need fixing, why would I work on it? All right, so I'll give it a shot this way. That means I'm going to group the first 2 together and the last 2 together, okay? What can I take out of these first 2?
X squared.
All right. I take out an x squared. What do you multiply x squared by to get x to the third? What do you multiply x squared by to get negative 3x squared? Okay, so here's the rule on group factoring. In order to group factor, I have to create this same factor over here. If you can't create x minus 3 over here, then it won't work. That's when I would go back up here and I would say, well, I probably need to rearrange these factors. You can rearrange the factors here and still get the same answer, just do it a little bit differently. It's not a big deal, okay? But remember this, when you move a term, like if I was going to move this 3x squared, what would I always have to take with it? Yeah, it's a negative 3x squared. You can't just leave the sign there, all right? So if I rearrange stuff, just be sure and take its sign with it, okay? Now, what do I need to take out right here so that I'm left with an x minus 3?
Negative 16.
Okay. And y'all, even if it were a positive 16, you'd have to put the plus sign down. It's the sign and the number. Okay? What do you multiply negative 16 by to get negative 16x?
Positive.
What do you multiply negative 16 by to get a positive 48? Okay. So there's that common factor. Y'all, if you can't create that, you can't do group factoring. Okay, so now I'm going to go chase a rabbit for just a second, all right, because I want to show you something, because this is the place where I have kids make mistakes. And so I want to show you something, and then I want to transfer that knowledge over here. So what if I had 4x minus xy? Do they have a common factor? X. You see what I'm saying? He's a factor here, he's a factor here. A factor is just something multiplied by it, okay? So if I take that x out, would you ever go, well, I took one out of here and I took one out of here, so that's an x squared? Would you ever do that? No, that seems crazy. He doesn't have an x squared. You can't take an x squared out. All right. So how many terms are right here? 2. 1, 2. What do those 2 terms have in common? X minus 3. So I'm pulling that x minus 3 out. Come on, pen. X minus 3. Now here's where kids want to put a squared up there, because they see one here and they see one here. It's the same thing as it was right here, guys. Okay? You didn't pull out an x squared right here. Don't pull out an x minus 3 quantity squared here. Does everybody understand that? What are you left with right here?
X squared minus 16.
There you go. Here's another way to look at it. You take what factor they have in common and you write it down. Whatever's left, you just squish it together in the parentheses. That's it. All right? Are we through? It is the same answer, because look, that's right, because look what this is. This is x minus 3, wait, let's see, x minus 3 times x squared, and this is x minus 3 times negative 16. Okay? All right. Now, are we finished?
No,
Why?
because
X squared minus 16 factors into some more. Don't drop that x minus 3, okay? What does it factor into?
X
plus
X, wait, what?
X plus 4 and x minus 4. Conjugate. Does it matter which order you write them in? No. Why? Multiplication is commutative. Very good. All right. Anybody got a question?
That was a question on our test.
It was. It sure was. I did, but still kids miss it. I mean, how many times did I say that? A bunch of times, all week long I said. Now, why can we do that anyway? And multiplication property of commutative property of multiplication. And then a bunch of kids said, it asked, does the order affect the answer? And y'all are like, no, because whichever way you multiply them, you get the same answer. I'm like, you just restated the question, people. No, why? Because the commutative property of multiplication allows you to do that. Okay? All right. So here we go. You ready for yours? Here's yours. Yours is 27t to the third plus 45t squared minus 3t minus 5. Factor completely.
I hate T as a variable. It's like I'm writing 3 plus plus.
Put a little tail. Yeah, put a little tail on it. Mm-hmm. Okay, you got it? All right, you ready, guys? Okay, I'm going to try and group them like this. All right? So look at these first two terms, 27t to the third and a 45t squared. Between 27 and 45, what can I take out? 9. Between t to the third and t to the second, what can I take out? T squared. Now, look, don't panic if you rearranged them. Okay? Second period, the kids did the same thing. I think that they probably saw that 27 and that 3 and wanted to do that, and the 45 and the 5 and put those together. It's fine. We'll all end up with the same answer. Okay? So, not a big deal. What do you multiply 9t squared by to get 27t to the third? What do you multiply 9t squared by to get 45t squared? Okay. Now, what can I take out of this? Y'all, I have to be left with a 3t plus 5. Yeah, just take out a negative 1. What do you multiply negative 1 by to get negative 3t? And what do you multiply negative 1 by to get negative 5? So, take their common factor and write it down. Shove everything together. 9t squared minus 1. What do you know about that? Difference of two perfect squares. So, I have 3t plus 5 times, what does it factor into? All right, anybody got a question? Okay, do y'all need another one? No? One more? Sure, I'll give you one more. All right, here's your next one. Look, this is on page 357, okay? Page 357. It's the last one in that group of problems. So what does that tell you? It's probably one of the more difficult problems, okay? Probably one of the more difficult problems. So they use a C, but I'm going to use an X. 4x to the third plus 8x squared minus 9x minus 18. Go. You have 2 minutes. All right, are you ready? Everybody okay? All right. So I grouped these first two. I took a 4x squared out, and I was left with x plus 2. What can I take out right here to be left with x plus 2? Negative 9. And you're left with x plus 2. So take your common factor and shove the rest of them together. Now, one of the kids asked last period, said, hey, Miss Davis, are you always going to be left with a perfect square right here? Are you guys? No, you're not. They're just, we have on every one we've done, but they're just trying to get you to look for things like that. And for you, when you see two terms and a minus sign in between, are those perfect squares? So can I factor it some more? They're just trying to kind of bang that in your head. Okay? So, this is the difference of two perfect squares. What does it factor into? Very good. All right, so anybody got a question? Okay, so let's look at some other type of factoring problems. We've learned really all the factoring skills that you need to know, but what if they throw some 6 in there and try to mess us up? Like example 4A, okay? This is the problem that they give us. 16, and it says factor completely, okay? So you keep factoring until you can't factor anymore, okay? We're probably trying to get it down to x to the first, but that's not always possible, okay? So 16 x to the fourth minus 81. All right, so the first thing my brain says is, hey, I got two things right here, and it's subtracted. Is this a perfect square? And then I look over here and I go, whoa, wait, 16 is a perfect square, but what about x to the fourth? I'm used to an x squared. What is the square root of 16x to the fourth? Yeah, it's 4x squared. So this is the difference of two perfect squares, isn't it? What's the square root of 81? 9. So what does this factor into? Very good. 4x squared plus 9 or minus 9, whatever, and then the other one, his conjugate. All right? Good. All right, so we factored it. Are we finished?
No.
Why? Yeah, y'all, this one, will this one factor? No, the sum of squares does not factor. So 4x squared plus 9. Don't drop that. Okay? Your brain's thinking about this. You're trying to hurry up and write the problem down. Don't drop his buddies. So 2x plus 3 and 2x minus 3. Order does not matter. Okay? They can be in any order that you want to. All right? Anybody got a question? Okay, let's look at another one. This is 4b. It's the same thing, guys. It's the same thing. It's not different factoring. It's just using it in a different way. So this is what this one looks like. 2p to the 8th plus 10p to the 5th plus 12p squared. Okay, so what you want to do? Very good. 2p squared. What do you multiply 2p squared by to get 2p to the 8th? Perfect. What do you multiply 2p squared by to get 10p to the 5th? Awesome. And 2p squared times what is 12p squared? Okay. So now I look at it and I go, whoa. Wow, I've never seen anything like this. But y'all, you have. If this said x squared plus 5x plus 6, you could factor it, couldn't you? Okay? So let me tell you what the stipulations are. The stipulations are this exponent right here has to be half of that guy. If this middle exponent is half of that one, it will factor. And not only will it factor, but he's telling you what it factors into. Okay? So, is 3 half of 6? So, I can factor this thing. All right. What's going to be the mistake right here? Don't drop that 2p squared, guys. Don't drop that. So now, because your brain is just going, factor it, hurry. All right? So what does p to the 6th factor into? Yeah, y'all, that's what it factors into right there. He's telling you what the answer is. P to the 3rd and p to the 3rd. What does a plus sign at the end mean? They're both the same, and they're the same as the first one. So plus and plus. The factors of 6. Look, people, 1 and 6 is what my head's screaming. Is it right? No, because I'm not subtracting. 1 and 6 and 2 and 3 are the factors of 6 who adds to be 5. 2 and 3. All right. Now, can I factor these? Why not?
There's no cubed root of 2.
That's exactly right. No, cubes you can do, sums and differences of cubes. But y'all, this is not a perfect cube. And this is not a perfect. What if it looks like that? Oh, you better bust out and factor that thing. P plus 2, p squared minus 2p plus 4. Okay? But this was just a 3. And since they're not perfect cubes, then that's as good as that one gets. Okay? All right, now let's look at a weird one. This is example 5. Okay? Example 5. It says, what are the real number solutions of 4x to the 5th plus 216x equals 60x to the 3rd. First of all, you just look at that and you go, what? That's some big numbers. Okay? So, what degree polynomial is this?
It'll be 4 degree 1.
It's a 5th degree polynomial. His highest exponent is 5, so it's a 5th degree polynomial. Now, I've said this a lot. The other kids, when I told them this, they're like, you've been saying that for a long time, Miss Davis. I go, I have been saying it. I didn't know if anybody's listening, but I've been saying it. Okay, so this degree right here, there was a guy back long, hundreds, thousands years ago, all right, and his name was Freddie Goff, and he discovered, they call it the fundamental theorem of algebra. He discovered that this highest exponent tells us how many answers we're going to get. So if he's a 5th degree equation, how many solutions is he going to have? 5 solutions, okay? Now, here's the problem with that. You say I'm going to have 5 solutions. Well, they don't all have to be real. Yeah. Some could be imaginary, all right? And the real ones could either be rational or irrational, all right? So, but I know there are 5 of them. Okay, so I'm going to show you 2 ways to work this problem. One way, you're going to go, oh, that's the way I'm always doing it. But then after we get started, you're going to go, I'm not sure that ended up being the easiest way I thought it would be. So I'm going to set this equal to 0 first, which means all I'm going to do is carry this term over here and change its sign. So 4x to the 5th minus, I'm just subtracting 60x to the 3rd from both sides. And then it's equal to 0, which is the same thing as what? Y. Okay? So I'm going to plug it in my calculator first, and I'm going to show you. Now, why can I plug this into my calculator and look at it? Because it's Y. But what is it going to tell me? What do I care?
It's going to show you your graph.
How many zeros it has? What are zeros on a graph? X-intercept. X-intercept. So, and look, they only asked for real number solutions. So, is the graph going to ever show me imaginary solutions? No. All right? So, he's only going to show me the real number solutions. So, we're going to take our calculator. Everybody needs to do this. Okay? You need to go to y equals, and you need to plug your equation in. 4x to the 5th minus 60x to the 3rd plus 216x. And then I would just graph it on a standard 10 by 10, which is Zoom 6. Now, how many do I know there are going to be? 5. But I don't know about them being all real and everything. So, how many do I see right here on my graph? 4. Now, see, you don't know this yet, but I know this, so I'm going to share it with you, okay? One of them's missing, isn't it? All right, that's a problem. That's a problem. Because, Spencer, if that were an imaginary root, they come in pairs. Not one, but pairs. Because of that plus or minus, that square root thing. So that tells me right now that I'm like, that thing's not imaginary. It's only one of them that's missing. So evidently my picture is not looking very good or something. So I'm going to go to my table first, because the table might be an easy way to find some of them, right? So I'm going to go second in table. Now, right off the bat, do you see the one that you didn't see? What is it? That's it. Y'all, this thing comes down here, and it crosses right here. You can't see it because it's so skinny. See how close those things are together? All right? You don't see it, but this right here says, oh, but he does. Okay? Now, later on in this chapter, we'll talk about some other things that we know will happen. All right? Pretty cool stuff. But right now, I'm just going, I know there's one right here. I also see that there's one at 3. That's this one outside here, which means this one over here is probably what? -3. And I could arrow up here and go, oh, yeah, there he is. So now how many do I have? 3 of them. So I'm missing 2. Do you agree that there are these 2 right in here? Okay? Look, if I look at my graph. You see these? They're in between 2 and 3 and -2 and -3. You see them? So they're probably irrational, but they're certainly not integers. Okay? So I could go to my paper right now and I could say, hey, man, I know 0 -3 and +3 are 1. I'm missing those other two, but I'm going to find them. Now, do you think it's going to be hard to find them?
No.
Do you know how to find zeros on your calculator? What do I do? Yeah, second and calculate. Now, what am I calculating? A zero, people. That's an x-intercept, an answer, a solution, a zero, or a root. All of those things mean the same thing. So I'm going to choose number 2. And then before we get started, I'm going to tell you we're going to have an issue. Okay? So it's not going to be quite as nice as you think it's going to be. And as soon as my spider took off, I said, uh-oh, we're fixing to have a problem, guys. And sure enough, we did. All right, so I'm going to talk for a second. My spider's right here, right? I'm going to find this one on the left first. So I'm going to press the left arrow key, and this thing's going to travel to the left. He's looking for a left bound. A left bound of this 0 right here, would that be above it or below it? Above it. Very good. So I'm trying to get over here. But watch what happens as soon as I press my left arrow key. Whoa. Yeah, he didn't just gently step down there, did he? He took a giant leap. Do you understand that? How do I know he took a giant leap? People, he's at -45. Dadgum, he went from 0 to -45. All right? So, what's going to happen? We're not going to see that spider when he comes back up here close to this point. All right? So, what am I going to be looking for to see? Because I want the Y to go from what to what?
Negative.
From negative. So as soon as the sky goes from negative to positive, then I know that thing jumped over there. You have to have a 0 in between there. All right? So while I'm going to keep pressing it, look, what's he doing?
Going farther down.
He's still going farther down. Oh, my word. Please, mister, come back up. What's he doing now? He's coming up. All right. So I'm like, oh, I thought I was sneaking up on it. What happened? He went. Look, down here he's -17. I pressed the thing one time. Now he's at +13. So what do I need to do right now? Press enter, people. You're on the left side of it. You're above it. So I'm going to press enter. You can barely see my little boundary arrow come up right there. Okay? And now he wants a right bound. So what am I going to do? I'm going to press the right key. And really, I know what's going to happen, don't I? I'm not going to see him. All right? He's like Flash Gordon. You're not going to see him, but he's going by. All right? Do I need to press it again? No. He's already down there, guys. He's at -17. So I'll press the enter key. There's that other arrow. Look what he's fixing to do. He's asking if I want to guess. I don't want to. I just want him to tell me the answer. But he set my boundaries. They're right here. So I'll press enter and say, give me the answer. And there it is. -2.45 is what we're going to call it. All right. Everybody okay so far? If you did the other side, the same thing's going to happen, guys. But you could find it. I'm going to tell you it is symmetrical. This one right here is +2.45. All right? So I think you should have the skills to find those. Even when wacky stuff like that happens, that just means you got to think a little bit, and you can't just be robotic at everything, okay, and methodical. You got to go, uh-oh, this is going to require some thought on this one. Okay, so let's write those numbers down. -2.45 and +2.45. Okay, so I found them all on the calculator. It may not always, well, for the real solutions I can do it, okay? But I'm going to show you the way that is the algebraic way, which is factoring this thing. So when I look at it, what should I do first? A 4 and an x. What do you multiply 4x by to get 4x to the 5th? X to the 4. What do I multiply 4x by to get -60x to the 3rd? All right. What do I multiply 4x by to get 216x? 50 what? 4? Oh, this looks like a little thing I can factor, doesn't it? Is he half of that first one? 2's half of 4? Okay. So what do you think x to the fourth is going to factor into? X squared and x squared. Guys, he's screaming at you. This is what you're factoring into, people. All right. What does a positive sign at the end mean? Same sign as the first one, so they're both what? Negative and negative. The factors of 54 are 1 and 54, 2 and 27, 3 and 18, 4 and nothing, 5 and nothing, 6 and 9, 7 and nothing, 8 and nothing, 9 and 6. Who adds to be 15? 6 and 9. Don't look at that 3 and 18 and go, oh, I got it, I got it, I got it. You're not subtracting, people. You're adding. This guy right here says you're adding. So 6 and 9. Oh, now what do we got? Difference of two perfect squares right here. Guys, will this thing factor? No. 6 is not a perfect square. That's like that cube thing we did in the last problem. So we'll just leave him alone right now. I'll show you how to work him. What's this going to factor into? All right. Now, watch this. Let's see who remembers this stuff. If x minus 3 is the factor, what's the root? Very good. If you set that equal to 0, what would x be? Okay? What would this be? Negative 3. Oh. Now, wait a minute. What about this one right here? Now, that's 0. If you set 4x equal to 0 and you solve for x, x would be 0. Now, this guy right here, he's kind of crazy. What if I set x squared minus 6x equal to 0? How can I solve that? Yeah, add 6 to both sides. Take the square root. Whenever you're solving an equation and you take a square root, what do you have to put? Plus or minus. Wonder what the square root of 6 rounds off to be. 2.45. There you go. So there he is right there. Plus or minus the square root of 6. And it is negative 2.45 and positive 2.45. Okay? So, this way's good. When's this way not good? Oh, what if you have one that will not factor? Then you just have to look on your calculator right now and see. Okay? All right. So, everybody okay so far? This is everything. Okay? This is everything. I think I'm even going to stop right there. I was going to work one more problem, but I don't think I'm going to. It's an application problem. You're not going to have one on your test, so I think you'll be okay. All right. So, I'm going to give you the rest of 10 minutes in class. If you don't have your worksheet, I'll give you back your worksheet. If you do have your worksheet, I'd start at number 21, and I'd try to work me a couple of problems. Going to start off factoring and see where we are, okay?